Linearly dependent independent vectors. So we have learned a lot about them, and here are 3 questions for you to test how much have you learned. And these are very simple and basic questions. So read them carefully and then answer. Are 3 vectors lying in a plane linearly independent? Explain. Next is, given 3 vectors in a plane, under what condition is it impossible to express one of them as a linear combination of other 2? And the last one here is, can any set of 3 non-collinear vectors be used as a basis for space? Now think about it and answer these questions. Now if you think over what we have learned about linearly dependent and independent vectors, you will recall that there were 3-4 terms which we were using always. First is non-zero. The next one is non-collinear, coplanar. So these are the key words which should help you answer these questions, right? So let's go through this once again and see how those keywords make a lot of difference. The very first is, are 3 vectors lying in a plane linearly independent? Well, the 3 vectors are in a plane, that means they are coplanar, right? So coplanar will be actually linearly dependent, right? Not independent. So this statement is false. Why? Because they are coplanar, right? So these vectors are coplanar. So coplanar. So the coplanar vectors should be linearly dependent. Correct? Not independent. That is one thing. Second, if there are 3 vectors and they are linearly dependent, will they be always linearly dependent? None of them should be 0. So they should be also non-zero. If they are non-zero, so that means if you combine these 2 properties, coplanar and non-zero, then only you will get linearly dependent, otherwise you won't get, correct? So the answer is that if 3 vectors are coplanar lying in the same plane, then they can be linearly dependent. They are of course not independent, right? They can be expressed in terms of the other vectors, right? Which is actually the next question. So the next question is, given 3 vectors in a plane, under what condition is it impossible to express one of them as a linear combination of other 2? So that means you can express as linear combination. Of course they are dependent. So for them to be dependent, they should be non-zero. So non-zero is the answer here, right? Can any set of 3 non-collinear, so now we have vectors which are non-collinear. So can any set of 3 non-collinear vectors be used as a basis for space? So when we say for space, then we are trying to say R3, right? And basis is next word, as most of you are using as span, right? So can any set of 3 non-collinear vectors be used as a basis or can be used to span in R3, right? So here the keyword is non-zero, right? So again you have to add non-zero. So these conditions are actually very critical, and if you miss these conditions, then your statement is false. So whenever you're getting across true or false type of questions, or like these communication type of questions, take care that the keywords non-zero, coplanar, collinear, they are properly used, right? Otherwise it may have entirely different meanings. So remember that. Thank you.